Tomorrow we'll do sum and difference for tangent and XYR problems. But today's just going to be sum and difference for cosine and sine. Sum and difference. Where did mine? Do you agree that... Oh, and we're doing cofunctions. I forgot about cofunctions.
What?
Cofunctions are quick. Can I change this? Sum and difference. I'll write it at the top of the next page too. Sum and difference identities. All right. What is an identity to start off? Let's remind ourselves. What are identities? Identities are equations that is true for all values of theta. So the cofunction identities. The first one is the cosine of pi over 2 minus a theta is equivalent to the sine of theta. By the way, you have a quiz A on Friday. Your quiz is just strictly over identities. The ones that you learned last time, plus the ones that we are learning today and tomorrow. So this is one of them. The cosine of pi over 2 minus theta is equal to the sine of theta, as well as the sine of pi over 2 minus theta equals, anybody want to guess? The cosine of theta. What does this mean? You don't know. You're like, I don't know. What is pi over 2? 90 degrees. So if you subtract your angle from 90 degrees, the sine is equivalent to its complement. For instance, I want you to think of the unit circle. What's the cosine of 30 degrees? Cosine. Root 3 over 2. Does everybody agree the cosine of 30 degrees is root 3 over 2? What is 90 minus 30? What is the sine of 60 degrees? So, same thing. So, let me write that down so those of you are like, what is she even saying? What is the cosine of 30 degrees equivalent to? The sine of 60 degrees. Do you agree the cosine of 30 degrees is square root of 3 over 2? What is the sine of 60 degrees? Square root of 3 over 2. Wow. Does that make sense? Hey, what's the cosine of 45 degrees? What's 90 minus 45? What's the sine of 45 degrees? Likewise, example 2, what would the sine of 52 degrees be equivalent to? Why the cosine of, not 48, 38. Why the cosine of 38 degrees? Because it needs to add up to 90. Okay? And that's what this means. Does that make sense? That's all you need to know about cofunctions. That is going to be on quiz A. This identity, knowing these identities, will be on quiz A. So the cosine of, and the question will be like, what's the cosine of pi over 2 minus theta? It equals, and your answer would just be sine of theta. Okay? All right. Next thing we are doing is sum and difference. Who is yelling and why? Who are you yelling at and why? Okay. Do you agree that if I give you x plus 3 squared, you cannot just distribute that squared and get x squared plus 9? Yes. Do you agree that's wrong?
Yes.
And we have learned that we are not allowed to do that. Yes. The same thing applies when you have the sum of cosines. When you have the sum of a cosine of a plus b, you cannot just distribute this and get the cosine of a plus the cosine of b. It does not work like that. That is not equivalent. Please do not do that. So what you are going to do instead is, we're going to show you. What you're going to do instead is we are going to do the sum and difference identity. The cosine of a plus b is equivalent to the cosine of a cosine of b minus the sine of a sine of b. There is an entire proof, aka verification, of why this is true. Would you like me to give that to you?
Yes.
We don't have time. I can give it to you later. But this is the identity. This is true. Likewise, the cosine of a minus b is equivalent to cosine a cosine b plus sine of a sine of b. These are your cosine, sum, and difference identities. How do I memorize them? Cosine starts with cosine. Cosine, sine. Cosine, sine. It is always AB, AB. And what about the signs? They're opposite. Bam. That's part of quiz A. What questions can I answer so far?
Is that the quiz A question?
That's one of them. I think you have 10.
How much time? Is it just the same question?
For a minute. What are you confused about? Like, okay, y'all remember quiz B last unit? Hold on, let me find it real quick. Yeah, like this. Your quiz on Friday is going to look like this. But instead of all of these, it's going to be the ones we're doing. Plus some of these. Just the front. That's it. Probably. Yep. 5 of them are going to be one of them on here already, and then the other 5 are going to be the new ones we're learning right now. Nope, that's it. Quiz, if you look at the calendar in front of you, quiz A, I think, is worth 40 points, and then your quiz B, which is on Tuesday, will be worth 60 points. So they'll make one grade. All right, the sign of A plus B, is a little bit different. It is the sine of A cosine B plus the cosine of A sine of B. This one's a little bit more challenging to memorize, but the way I memorize it is sine starts and ends with sine. And it's still AB, AB. What about the sine of A minus B? Sine A cosine B minus cosine A sine B. And what do you know about signs? Sine has the same sign. If this is plus, this is plus. If this is minus, it's minus. It's still AB, AB. And again, sine starts and ends with sine. Cosine is cosine, sine. Starts with cosine. But sine starts and ends with cosine. So, how can I use this? Can you Find the exact value of the following. What function is this? Why is it sine? It starts with sine, so I know this is going to equal the sine of something. Is it plus or minus? Why minus? Sine has the same sign. So it's minus in the middle, it'll be minus. And your A and your B are just angles. What are my two angles here? A and B. 80 degrees and 20 degrees. By the way, this should always end up with something on your unit circle. So what's 80 plus 20? Is 100 one of the special angles on our unit circle? So we know that probably won't be it. Okay. What's 80 minus 20? So this equals the sine of 60 degrees. What is the sine of 60 degrees? Root 3 over 2 is my answer, and I have simplified this. What questions do I have? We're okay? Did I go too fast?
So whatever it starts with is the answer?
Correct. Let's try this one. Which function is this? Starts with cosine, so it's cosine. And do y'all agree I have 40 and 20? And what do we know about cosine? Opposite sign. So this is minus, so what's it going to be? Plus. And, right, 40 minus 20 is not on our unit circle. What's 40 plus 20? And what is the cosine of 60 degrees? How are we feeling? Okay. Okay? We ready for a quiz on this?
Yes.
What about this one? Do I need to lift it up, or y'all okay?
Oh, I get it.
Sine or cosine? Cosine. Am I going to add or subtract? Why add? Because it's the opposite sign. Do y'all agree with that so far? What does that add up to when I add them? Do you agree I can make them both over 12 by turning that into 3 pi over 12? Do y'all agree with that? They're equivalent. And then that's going to give me 4 pi over 12, which is pi over 3. And what is the cosine of pi over 3? Bam. This is working your sum and difference backwards. I'm giving you the sum and difference expression, and you have to find the exact value. We tend to like this the best. I see a couple people writing, so I'm going to wait to change it. And now we're going to go the opposite direction. You good? You good? Okay. Just wait. All right. Example 2, we're still going to find the exact value. But this time, all I'm giving you is this. That is not a lot of things, right? Is 15 degrees on your unit circle? I mean, yes. But is it one of our special angles on our unit circle? No. So how can we find the cosine of 15 degrees? We can use the sum and or difference identity. Can I add 2 things on my unit circle to get 15? 2 of my special angles? No. Can I subtract 2 of them? Which 2 numbers on my that are my special angles can I? Could you subtract 45 minus 30? Sure. Or 60 minus 45? Does that give you 15? Sure. Or could I subtract 135 minus 120? Sure. I would stay in quadrant 1 if you can stay in quadrant 1. But could you do 225 minus 210? Absolutely. If that's what your heart desires, go for it. But I'm going to stick to quadrant 1. So are y'all okay with me saying, hey, this is equivalent to saying the cosine of 45 minus 30 degrees. Are y'all okay with me saying that? Does this say, remind me later, okay. Does that make sense what I just did? I'm just choosing 2 degrees on my unit circle that make that work. Well, now guess what I have? I have A and B. And now I'm going to write my identity. What identity are we going to be using? The cosine of A minus B. I want you to write out the entire identity. That will be 1 point for every problem. So what's the cosine of A minus B? What's that identity? Cos. And it's going to be y plus, because it's opposite for cosine. And then sine. Remember, it'll always be AB. And now I'm going to substitute in hours. The cosine of 45 minus 30. Everywhere there is an A, I'm going to put 45. Everywhere there's a B, I'm going to put 30. I would like you to put the degree sign. I will say that there are just so many opportunities to count off for it. I don't know if it might be half a point. I don't know. I haven't decided yet on that. I would definitely put a degree sign though. All right, y'all. What's the cosine of 45 degrees? Root 2 over 2. What's the cosine of 30 degrees? Root 3 over 2. Plus, what's the sine of 45 degrees? Your unit circle is not going away. And what's the sine of 30 degrees? What questions do I have so far? None. What do I do next? PEMDAS. Multiply. What is the square root of 2 over 2 times the square root of 3 over 2? Square root of 6 over 4. Multiplying, you multiply the top, multiply the bottom. Plus, what is the square root of 2 over 2 times 1/2? Root 2 over 4. How do we add those? Look up real quick. Look up. I can multiply radicals. Can I add radicals?
No.
So your answer is the square root of 6 plus the square root of 2 all over 4, because you keep your denominator the same when you add. And that is our answer. Oh my goodness is right. Definitely be on the test. Y'all will get, like with practice, once y'all do the homework, these will not be bad. Y'all will get good at these. It's your first time seeing it. You learned about this in Ms. Dank's class?
Yeah, you learned radicals.
Oh, radicals, adding and subtracting. What questions can I answer? Does each step make sense? Does everybody see why we chose 45 and 30? Did we have to choose 45 and 30? No. And then you're just plugging into the identity. Let's do another example. What about the sine of pi over 12? All right, radians are a little bit more difficult. Do you agree this is 1 pi over 12? Do you also agree the only way I am going to get 1 pi is probably to subtract something? Okay. Something over 12 over something over 12. Now, what minus what will give me 1? 2 minus 1. I'm so glad you said that. If I did 2 pi over 12 minus 1 pi over 12, let's reduce those. 2 pi over 12 is pi over 6. That works. That's on my unit circle. But does pi over 12 reduce? No. That one I don't want because it's not on my unit circle. 4 and 3. 3 and 2. 5 and 4. But if I were to choose 5 pi over 12, does that reduce? No. So I probably don't want that one. So what do y'all want to do? 3 pi over 2? Or 3 pi over 12 and 2 pi over 12? Cool. You could also do, actually I'm going to do 4 and 3, but you could do, it doesn't matter. I'm just going to do it because I don't want to use the same numbers we just did. You could do 3 and 2. I'm going to do 4 and 3 just because 3 and 2 end up being those two numbers. What is that equivalent to if I reduce these? Pi over 3 minus pi over 4. Does that make sense? Now we have an A and a B. What trig function are we using here? Sine. So I'm going to write my identity. It's going to be A minus B. And what is the sine identity? Sine of A, cosine of B, and it's same sign. Sine has the same sign. Cosine of A, we got to end with sine. We start and end with sine. I'm just copying this identity from the front. And then now let's plug in what we know. Does anybody, while y'all are doing that, does anybody need me to re-go over how I chose these right here? Yes. Why'd I put what? I don't know. Thank you. That should be a B. Thank you. What else? All right. We'll just fill this out then. Sine of pi over 3 minus pi over 4. Write this down, please. Anthony, you with me? Gerard, are you with me? What is the sine of pi over 3? What is the cosine of pi over 4? The cosine of pi over 3? And the sine of pi over 4? What does that give me? It is not the same thing. Why not? It's just minus instead of plus. I wouldn't even call it either one of those. It's just minus instead of plus. Conjugate would work a lot better than either one of those words y'all use. All right. All right, I'm going to give y'all about 5 minutes to do this one, while I figure out what two numbers that add up or subtract. Oh, got him. What two numbers add up or subtract to 17? Is that 75? And then they can reduce to Z on our unit.
It's clicking.
So like you don't want to do 7 and 10 because we can't reduce 7 pi over 12. Oh. Yeah, that works. Did you do 2? 3. Yeah, you could do 215. 3 and 14. 3 and 14.
Are you dumb?
Because those will look reduced. So when you're doing it, there will be multiple A's and B's, but at the end you should get the same answer regardless of what your A and B was. Correct. Correct.
Wait, does 8 and 9 work?
8 and 9 works.
Yes.
2 and 15 works. 3 and 14 works. So somebody asked, well, how can we do this if there's so many answers? There are different A and B's, but when you get down to your final answer, they should all be the same. Yes, somebody said NIST. What did y'all use?
8 and 9.
8 and 9. Did anybody use anything different?
It's negative, positive. X is negative. It's going up. Yes, bro. Look at the board.
Did anybody do other numbers besides 8 pi and 9 pi? What'd you do?
6, 7. Sorry.
Anybody do anything else? It should still work no matter what you do. The bell is about to ring. If you didn't finish, we'll finish this up tomorrow. Thank y'all so much. No homework tonight unless you want to do odd problems.